need it. Right. So, first time pala lahat, no, ng GeoGebra. So, this is the title of the seminar, the webinar workshop. It's called GeoGebra and Function Art. And does anyone know about function art? Have you heard of it? Anyone heard of it? Can you raise your hand? Mukhang wala pa, no? At baka nga wala pa because this is the first, ano, no? This is the first, I mean, I coined the term, so this is something new, no? So this is the outline of our workshop. First, we are going to learn a little bit about GeoGebra. You don't need to be an expert in GeoGebra to do function art, so we'll discuss GeoGebra a little bit. And then we also, of course, we discussed the interface. No? So you're familiar, you will be familiar with it. And we will do graphing. No? Do graphing in GeoGebra, graph the basic functions. And of course, no, some of you, maybe you have more advanced, you have already learned about uh, functions and maybe even parametric equations. So you can use that, of course, in your artwork later. And we're also going to look at the overview of the artwork. So at the end of the webinar, we're going to have a short demo lesson on how to do the artwork. Yeah. But before that, we talk about the transformation of functions. No, I'm not sure if this is highlighted in the university because when I'm giving to high school, I think this is not highlighted. The transformation is not highlighted in the high school curriculum. That's why I had to put this now. We're going to talk about domains and intervals, and this is needed because you have to define the domain of the functions when you cut the graph into finite arcs, no? And we are going to um, also do, no? I'm going to teach you how to do the artwork, and and then we have a summary, and then I'll show you some of the students' artwork now. So basically, this webinar has been implemented in different schools, no, many times. So I can't even remember because this study has been going on for the past 3 years now for my PhD, and I've implemented it also not just in the Philippines but also in other countries like Egypt, Tanzania, what else, and some countries here in Europe. No? Right. So what is GeoGebra? So GeoGebra is a dynamic mathematics software for teaching and learning mathematics that combines algebra, geometry, calculus, statistics, and spreadsheet in one package. So if you're probably the first thing that you will ask is it free? Yes, no, yes, it is free. You can download it from its website, geogebra.org. You can also um, use GeoGebra using your browser. So here, if you go to geogebra.org classic, no, I'll put it again in the link in the chat so that the other people who just came in can access it. So you will see its environment. Later on, we will going to learn a little bit about the environment. Um, and what's good about it is it's free, of course. You can download it almost on all devices. If you're using laptop or tablet, no, Android, even Android or iPad, no, iOS. And if you're using a computer or a laptop, it's also available on both in Windows and also if you're using Mac and even if you use Linux, no. So it's available on almost every platform. You can also download it from the App Store if you're using iPhone or from the Google Play if you're using Android. So basically, you can download it using any device. No, Now, if you open GeoGebra, you will see this environment. No, so if you open this, if I uh, open GeoGebra, you can, of course, if you have downloaded it, you can open it from your computer. Later, I'm going to give you the download website. But now you can use the browser since you're connected to the internet. So what you see, of course, you can see the tools here. This is called the toolbar. You can see the different tools. Okay. And here on the left side, this is what you call the algebra view. So the algebra view contains the algebraic representation of what you do here, what you draw, no, here. So for example, I draw a polygon. So this is a polygon tool. I can see all the objects here in the algebra view. So I can see the 3 points that I created. I can see the polygon itself. This is the T1, and the number that you see here is the area. And I can also see the line segments here. So the number that you see, these are the lengths of the line segments. So if I move, for example, if I move the points, of course, you will see also the movement in the algebra view. Okay. So this is very important. You are educator, so this is very important because we are usually in mathematics we highlight multiple representations. So here are the objects that you see are represented both algebraically, numerically, and also geometrically. Okay, so that's the part. I'm going to turn off my camera because uh, the zoom is okay. Okay, right. So here on the right hand side, the right top, this is the menu box. So this is where you save your file. So you can save both online and offline. So you can save in your computer the applet. The output is what you call the applet. You can also download it if you want. Well, of course, saving and downloading is the same. If you want to save online, you have to be logged into your GeoGebra account. So you will be recommended to log in because later when you submit your artwork, you have to submit the online version of your artwork. Okay. And then here, this is the style bar, what we call the style bar. So this is where you change the properties of the objects. Properties means color. For example, you can change the color. Okay. You can change the size and the style. So in some cases, you need to change the size and the style. So you can change. Okay. And this is, of course, a graphics view. This is where you do your artwork. This is all the graphical representations of your artwork will show, and of course, all the mathematical objects, the graphs. No, so you can remove if you click on this. No, you can remove the grid. You can remove the coordinate axes. No, and then you can do a lot also. If you have the grid, if you have polar coordinates, for example, so you can also have uh, so different grids, no, and the coordinate system. Okay, so and you can also graph, no, of course, not just geometric objects, but you can also graph. So if, for example, f of x equals x squared, so you can also graph like that. Okay, so I'm going to give you 5 minutes to just to feel, no, the software, just to maybe not 5 minutes, it's too much, maybe 3 minutes. 3 minutes to just look at the software and and play with it. And by the way, here on the top, on the bottom left is the keyboard. You can see the keyboard um, icon. You can see the keyboard icon once you put in the input bar. So if you click somewhere here, you cannot see it. But if you put in the input bar, this is what we call the input bar. When you want to type something, so you can see the keyboard, and if you click on the keyboard, you will see here. So these are the different. These are the different. One moment. Um, you can find the symbols here, the numbers. So if you need, for example, degrees or dollar or some mathematical symbols like integral, you can find it here. And of course, you have the text. If you need a Greek letter, for example, so you have to go to the ABC icon and then click on here, and you will see the Greek letters and also other symbols. Remember, you can only access this when you click on the input bar. All right. So I'm going to give you maybe 4 minutes to just explore. Again, you have to go to this website, and later we're going to teach you how to download it if you want to work offline. Okay, so for now, you go to this website, just experiment with all the tools, and also if you want to graph, try graphing. I'm sure you have used other software in graphing, so it's the same. And after 4 minutes, we will start our session. So it's 7:53 here. Um, let's resume at 7:57.
Hello guys. If you can open the GeoGebra link that was given to you and you can explore like this, then you could also do so.
All right. So I hope you have explored for even just for a short time, no? Right. So of course, in creating function art, we need to sorry, we need to learn graphing, no? And of course, graphing is just the same as graphing in any other software. So for example, if you want to graph, if by the way, if you're using online, no, online, um, if you're using online GeoGebra, you have to be careful because once you refresh, no, you refresh your window, what will happen is that um, all, no, all the objects that you have created will be uh, erased, no. So if I reload it, it becomes a blank window. So you have to be careful, no, when doing online, no, because I think a lot from experience, a lot of students, just lose their work because of doing it. So I think it's better if you do it offline. Although I think still many high school students they want to do it online. So up to you. So how do we graph, no, GeoGebra, for example? For example, f of x equals x squared. Of course, you can just type f of x equals x squared. So you have to look for this key, no, the caret key, no. I'm sure many of you knows this. So many of you know this because I think you probably have been graphing your math major, so you graph all the time. No? So you have to look for this key. I think it's above six. No, I'm using a German keyboard, so it's different. Let me check the other laptop. Yeah, it's above six, I think, in most English keyboards. Okay. Of course, if you can have also g of x equals x cubed. Okay, you can have that. You cannot have the same name, no, for different functions. So you have to use different names. One moment. So if you have already used f, you cannot use f again. So if you want, it's more organized. Just use f1, f2, f3, and so on. So you can also count the number of functions that you used. So some students do that, and then sin x. So maybe h of x equals sin x. Okay, you have that, and you can also do inequalities. So for example, y is less than x minus, was it negative x minus 3? Anyway, it doesn't matter. Negative. I'm using the German keyboards. X minus 3, for example. Okay, so you can have that. And also you can also do conics, of course, like circle, for example, x squared. What did I write here? Anyway, it doesn't matter. We just write some equation. Circle plus uh, this is my problem when I'm using a different keyboard because the placement of the keys are different. Sorry. This is plus y minus, well, maybe y plus 2 squared plus 4, for example. Okay, so that's a circle. So you can do inequalities, you can do functions, you can do conics. Bakit nga ba hindi function ang circle? So I'm sure you know this, no? So this is probably one of the questions of your students when you teach, no? Bakit siya hindi function? Bakit nga ba?
Anyone?
Mhm. Palagi ang sagot ng mga estudyante, vertical line test. So, it's correct, but if you look at the definition, yeah, for every x in the domain, you have to have two y values, no? So, actually, there are only two x's with only one y value, yung nasa dulo lang, di ba? But if you look at any of the points here, for x equals 3, for example, you have two values. Okay? So from the definition of function, you cannot have two y values. So at least you can have one, no? For each domain, for each x in the domain. Okay, so I'm sure you know this. It's math majors. Right. Okay, so why don't you try this, no? I'll give you 3 minutes. Just try graphing, no? Maybe one or two, and then try graphing the inequality and also the circle. 2 minutes.
Mr. Beltran, can you share your screen? Let's see how you are doing the activity. Are you on the GeoGebra app? Tingnan natin, sir, yung ano nila, screen,
Yeah,
kung
they
meron sila.
can screen, no?
Yeah.
They can share their screen. I don't know how do I set it up, but if someone wants to volunteer, of course, I can make
Mm-mm.
co-host, and then they can share your screen if you want, no?
Okay.
Okay. I think
Hello, would someone like to share his screen or her screen? Is Roan around? Roan? Hello, Roan.
Yes, sir. Good afternoon.
Can you share your screen? Are you with GeoGebra app?
No, sir. I'm only using a phone, sir.
Cell phone. Okay.
okay. So yeah,
Who's using a laptop? One. Okay. Go, Miss Kokotano. Okay. Yeah. This one, sir.
okay. So you can graph anything you want.
Okay, can you share something, Miss Kokotano?
You have to click outside. If you have clicked the this button, the you have to click outside that area, and then click again on in the input box.
Okay. Can you share again? For JR, is GeoGebra also can be done using the cell phone, right? They
Yes,
could
yes,
really
yes.
do it there. Okay.
Yeah. If there's really no device, then they
Yeah.
can.
No.
Some students actually use mobile phone in creating
Okay.
their. I think we have to proceed. Otherwise we will
Yeah.
be late.
Yeah.
No? Okay, so anyway, you can explore it on your own later. Uh, Next, this is the artwork that we're going to do later. So it's a very simple artwork. It's the Apple logo. And if you ask me why, well, it started from the Apple logo, so I stuck with it. I stick with it. So it was an abrupt invitation when I started this project, and I didn't change it. So anyway, it's very later you will see why we have chosen this. I have chosen this artwork. Right. So, but before doing the artwork, we need to have a bit of a review of the transformation of functions. I don't know if you're learning it, um, it's highlighted in your curriculum, but in many curriculum they are not highlighted. So what we will do is try to graph this, no, for 5 minutes, and then try to not really answer, but think about these questions, and maybe we can have a bit of interaction later. Maybe I'll ask some of you to answer these questions. No, these are not difficult questions, so I'm sure you will be able to answer them. Okay, so I'll give you maybe 3 minutes to do this, or maybe five, so you can think about the questions. And then we will discuss after 5 minutes. Try this and then try to think about these questions. Okay, so let's have a bit of a discussion.
Miss Gokotano, you can share.
Mhm. So what do you think? How is the graph of G, relate and the graph of H related to the graph of F? Anyone? Anyone would like to answer? You can raise your hand so we can see you because from my screen I cannot see you. Anyone? If you have graph, then you will be able to observe, right?
Roanne, would you like to share? Hello, Roanne.
Yes,
You
sir.
can unmute.
Based
Mm.
graphing it from my Desmos app, um, the three functions or the three expression shows the same in wavelength or the wave generally. They're all the same. It's just that the second function, the sine x plus two, is a bit elevated by two shifts. It's
Two
upward, and
units.
the third one is shift downward. That it, sir.
Okay, so that's correct. No, so if you can see, if we try to graph f of x equals sine x, no, so f of x, that's correct, no, f of x equals sine x, and then we have g of x equals sine x plus 2. Okay, so it's a shift, no? So the graph of G is a shift of the graph of X, of F by 2 units upward, no? And also, if we try the second one, the graph of H, this is minus 3, right? So so h of x equals sine x minus 3. And that's a shift by 3 units, uh, shifts down. And do you think this is also true for other functions? What do you think?
Missing Aya, would you like to answer if it's true to other functions aside from the sine function?
Okay, maybe we can try x.
Um,
We can replace it. Oh, okay, yeah, yeah. Just please answer.
yeah, continue, Missing Aya.
What is it again, sir? The question, sir?
Do you think is it true for other functions as well? If you add 2 and then it increases by it shifts by 2 to up, sorry. Is it the
Yes,
same?
sir.
Mm-hmm.
Yes, sir. But it going up 2 units then
All right.
since we add two.
Okay. So that is correct, no? So generally, when we add no a positive number to the output value of the function, it translates the graph up no by that number of unit. And also adding a negative number to the output value translates its graph down. No? Why do you think I put adding and not subtracting? Well, this is a bit of a math, no? Kasi math majors kayo. So we are talking about the math of it. And the reason why is because I don't know if you have abstract algebra. If you go to higher mathematics, there's actually no subtraction. No? The subtraction is a definition of adding the negative. No, and this has two purpose. One is it doesn't confuse the student because what if you subtract the negative and you subtract the positive? So subtracting the negative is also adding. So to avoid confusion, no, in fact, in other curriculum, they don't, in Japan, when the students already learn negative numbers, they don't use subtraction anymore. They always convert subtraction into adding of negative. So they have no confusion with the operations on numbers. on integers because they always convert, no? So this is the reason why we put adding here. So this is a bit of more of on the math and the pedagogy because you're teachers, you're going to be teachers. So hopefully you learn something aside from GeoGebra. And why do we say output, by the way? Output of the function. Later you will know why. What is the difference between adding to the output and adding to the input, which is the next transformation. So this is called vertical translation, by the way. This is called vertical translation. So here, another 5 minutes, you try to graph again the functions that are shown here and see what is the relationship between the graph of Q and the graph of R to the graph of B. So another 5 minutes. 8:19 here. We resume at 8:24. Okay, so in case you're wondering, no, we will learn four transformations. So we have two more after this. So bear with me, no. Um, so what's the difference between the graph of Q and P, and also the graph of R and P? What did you observe?
Gabriel, would you like to answer? Yeah, Gab.
Basically, sir, what happened to the graph if you add something inside if you add something to x, is the graph will, just like the previous one, if you add something, the graph will move, how depends on how many units you add on it.
But what's the direction this time?
If you add something, if you add one in it, or if it will move to the left, and if you add a negative number, it will move to the right.
Okay, so very good, no? And by the way, the others also can, of course, answer. No, you can also use the chat box, no, if you want to answer. So I think someone, yeah, it shifts horizontally. That's very good. So when you're teaching functions, maybe, and when you're teaching transformation, maybe the one of the discussions is why, So you always have to ask the students why this happens, no, and maybe this is something that you can think about later. So for example, in the vertical translation, it's probably easy to think or to answer why, because you're adding to the value of y. But here it's a bit counterintuitive. Why does the graph shift to the left when you add a positive number, and shifts to the right when you subtract a positive, add negative, when you add the negative number? So this is the things that you need to think about later, and maybe connect it with some of your lessons, no? So this is basically horizontal translation. So adding a positive number to the input value translates the graph to the left, and adding a negative number to the input value translates the graph to the right. So you will observe that I use input and output, and what is the difference between the two, no? So here, adding to the input in the first transformation, that's adding to the output. If your input is x, your output is actually sine x. So if you add 2 to the output, you add 2 to sine x. But here the difference in the second transformation, your output here is x squared plus 3x. And if you want to add to the output by 1, for example, that is x squared plus 3x plus 1. But here we didn't add to the output, but we added to the input. That's why all the x's became x plus 1 here, and all the x's became x minus 4 here. So I hope you make that distinction, adding to the input and adding to the output. Right. So third transformation. So just two more. After this, we are going to have to do our artwork. So just two more. So I'll give you another 5 minutes to think about this, and to graph these functions. Okay. So what happens if we multiply the output by 2 and by 3 and by 0.5? Oh, by the way, we didn't graph the second one, ano? I think we should graph this first before we proceed. So for this one, x squared plus 3x. Para lang makita nung iba na naka-cellphone, no? So they didn't, maybe some of you cannot graph the moment. So f of x equals, or I think we used p, squared plus 3x. Tama ba? Yeah. And then for q, we have x equals x plus 1 squared. So all the x's became x plus 1 and then plus x plus 1 squared, and then plus 3. Uh, let me just copy maybe this one. Having a problem with the German keyboard. Can't remember the placement always. Okay. So the graph shifted to the left by 1 unit. And you can see because the corresponding points, for example, the corresponding point here at x equals 0, it became x equals -1. And also probably you can also look at the vertex. No, it moved 1 unit, and also here. And also you can, by the way, you can click on duplicate input, and then you can just change. So this becomes -4. And you have to put -4 here. Okay, and then we can try r of x. Okay, so it moved 4 units to the right. No, so you can check the corresponding point. For example, this one. This is x equals -1. It becomes x equals 3. X is 0 here. It becomes x equals 4. So it moved 4 units to the right. Okay. And for the third one, we can try. What did you observe? You can type your answer, so we save time. You can type your answer in the chat box. Oh, is it Miss Makabecha? I'm sorry if I pronounce your name incorrectly. Just correct me. Okay, please.
Good afternoon, sir. As I have observed of the graph, sir, when we multiply a constant to the function, it uh, changes the scale or how it is stretched out, sir.
Mm-hmm.
For example, in the graph, I function g and h, since the constant that we multiply to the function is greater to 1, we can observe that its steepness or the way it is stretched out is different than function j, which is less than 1, sir. The function j shows a graph that is much flatter compared to functions g and h, sir.
Okay, that's correct. No, so the graph is a bit steeper, no, when you multiply by a positive number. So x cubed minus 4x. So let's try x cubed minus 4x. Okay. So let's change this. And then if we multiply by by 2, so what happens? No, it becomes steeper. No, it stretches vertically, and you can see. No, if you examine the points, remember that we multiply the output by 2. No, so meaning if the point here is 3, if the y value is 3, you multiply this by 2, it becomes 6. No, so you can see here 6. And for example, here y, if you look at the green graph, the value of y here is 2, and if you multiply by 2, y becomes 4. So because you're multiplying the output by 2, that's the output is actually the value of y. No? So these are the things that you can ask your student. Why do you think? No, why do you think this point is here? So the reason should be that, oh, so we multiply the value of 3 by 2, so it became 6. So those are the reasons that you should seek from your student. No, so they try to reason based on what they see. No, this is very important because you're education students, and hopefully uh, your student would be able to make connections between the graphical and the algebraic notation here, representation. Why are these points intersecting here at 0? Because if the value of y is 0, if you multiply by 0, it's also 0. That's why they are both the y values of these functions are at 0. Okay, so these are the questions. I'm telling you this now because we have no time, but if I'm going to teach you, I'm going to ask you why, no? And I hope when you teach, you also teach that way. Not just what do you see, but why. Why do you think that is? You always have to ask the why, no? Okay? And if you multiply by zero point 0.5, uh, we change this by 0 0.5 and change, for example, to h of x. So what happens here? The same, no? If you look at, by the way, you can hide and display the graphs here. So if you click on them, but if you don't need them now on your artwork, please delete them now because it makes GeoGebra slower if you have a lot of functions. So if you can hide, then you can hide the functions and you can hide it if you need them, but if you don't need them, just delete them. No. So if you look at the value of the function, if you look at f and h, we multiplied by 0.5 by 1/2, and what you can see here. So for example, the value of y here of the green function, this is 3. If you multiply it by 1/2, this value here is 0.5, and this is also the same here. At x equals 0, if you multiply 0 by 0, then if you multiply by 0.5 by 0, it becomes 0. The same here at this value. For example, at 2, what is the value of y at 2? This is 2 cubed. At x equals 2, this is 2 cubed. That's 8. And this 4 times 2 is 8. So 8 minus 8 is 0. Here, and of course, in every function, 8 minus 8 is 0. That's why your y value here is 0. And if you multiply by any number at 0, uh, still 0. So even if you multiply the function by any number, like even if I multiply this by 8, for example, they will still pass through these 3 points because at these points, the value of the function is 0. Okay? So I hope you make that connection. So this is a stretch. This particular transformation is a stretch. It's actually vertical scaling. It stretches the function vertically. So multiplying the outputs by a number greater than 1 will stretch the graph vertically. and the graph will look steeper, and multiplying the outputs by a number between 0 and 1 will shrink the graph vertically. The graph will look flatter. And this is more prominent when you use, for example, sine and cosine functions. You will see it better. No? Okay. Now the last one before we proceed to our artwork. This is the last one. And my question to you is, what happens if you multiply, by the way, by the negative number? So what if negative 3? What will the graph look like, do you think? Instead of times 3, I multiply by negative 3. You can type your answer. What do you think? If I multiply this by negative 3 instead of 3. Okay, someone answered. Is it shift direction? What do
Based
you
on
mean
the
shift
chat
direction?
box, sir.
What do you mean shift the direction? Shift in one. Yeah, that is, yeah, flipped. No, that is correct, no? So it will be flipped, and technically it will be reflected, no? So that is also one skill that you need to learn, no? To be more precise, no? Of course, we introduce the students to the term, but if you already know the term, you have to be precise, no? Okay, so this is the last transformation. Um, again, 5 minutes. Okay, so what's your answer? What is the difference between of the graphs of sine 2x and sine x, and then sine 1 half x and sine x? You can type your answer in the, or if you want to answer, you can just raise your hand. You can also use the chat box. Okay, we have one answer. Okay, faster oscillation. Okay. So this is good, no? Changing let me read from the chat. Changing the coefficient of x, the greater the constant you multiply to x, the faster the oscillation. Sine to x has a shorter period, more frequency, and twice that of just sine x. Right. So that's good answer, no? And of course, if you're studying physics, you have the oscillation, you have the I think you learn about period and amplitude, and you can apply this. But if you're uh, just learning math, so this is called horizontal scaling, or you can call it horizontal stretching, or horizontal squishing, no, in some books. No? Okay, so let's look at the graphs. We have sine x. We have sine x. Let me just type it. F of x sine x. And then we can have sine 2x and sine 1 half x. So as you can see, GeoGebra automatically creates a fraction. Of course, you can use decimal sine 0.5x if you want. So as you can see, what is the difference among the three graphs? So as Mr. what's the name? Is it Mr. or Miss? I don't know. Rowan can be a name of a male or female. So sorry, I don't know. So uh, the answer says that if you have multiply the coefficient of x by 2, the oscillation becomes faster. And the so as you can see here, if you look at the difference between the green graph and the red graph, this is indeed faster. No? Actually twice. No, it's faster by a factor of 2. And if you look at the blue graph, it's slower. No, it's stretched horizontally. So that is actually horizontal stretching in mathematics, no? Or horizontal scaling. So if you multiply the input, multiplying the inputs by a number greater than 1 will shrink the graph horizontally, and multiplying the inputs by a number between 0 and 1 will stretch the graph horizontally. So again, this is quite a bit counterintuitive, just like adding to the input, multiplying by the input is counterintuitive, because multiplying by a larger number will shrink the graph, and multiplying by a number between 0 and 1, a smaller number, is stretches the graph horizontally. So again, you can see this, no, as you have seen, you can see it more prominently if you use the sine and cosine functions. Right, so those are the different transformations. There are two more, no, that is usually discussed, but we don't have time, so you can explore it yourself. We have the reflection about the x-axis and about the y-axis. So we will give you that in our later in the GeoGebra book. We will give you the link. No, Sir Darren will give you the link to the resources, including this video. We will try to upload this on YouTube, but we will give you the link privately, meaning you are the only ones who can access it. So we don't need to give it to everybody. Okay, so just to emphasize, what is the difference between input and output? So this is adding to the output. So the plus 3 is here. This is your input, x, and this is your output. So the plus 3, as you can see, 5x squared plus 8x is the output. And then you add 3. What about input? All the x's became x plus 3 and x minus 3. Okay, and also in terms of multiplying, so multiplying the output, this is the same function as here. So if you multiply 5x squared plus 8x, if you multiply the output, this is the output by 3. And this one is multiplying the input by 3. And this one is dividing the input by 3. So dividing again is multiplying also. Dividing is just multiplying by the reciprocal. No. So if you have if you already have a subject on abstract algebra, then you will see that there are only two operations. At least the basic ones. These are the multiplication and the addition. So subtraction is just the addition of negative, and multiplication is just and division is just multiplication by the reciprocal. So only two: addition and multiplication. Okay, so that's the difference. And these are the transformations that we have learned now. So we will give you a copy of this PowerPoint for your reference later. So we know the transformations. Now, how do we create the artwork? We need to learn one more. We need to cut the function. Because of course, the function usually uh, extends indefinitely on both sides. So we need to cut, no? So how do we cut the function? So what if I only want the function from, for example, from -2 to 1? So what we do is we type the equation and then we type comma, and then what we type the domain using the inequality. So for example, from -2 to 1, I will type comma, and then I type x. X is greater than or equal to, or you can, if you want, you can just use greater than, is equal to -2 and less than or equal to 1. So if I press enter, so the GeoGebra only shows this interval. So again, this is the domain of the function. We define the domain to be this interval. So if you teach function art later on, if you teach function art, you learn also about the domain of the function, changing the domain of the function. And this is not usually taught in high school. Okay. So again, we have that here. You can use just, if you want to use strict inequality, then you don't have to put equal. And you can just type, this is how you type it, less than and equal. If you want to use the one with the equal sign. And also you can color, no? You can color between the region. So for example, if you have f of x squared minus 3, and then you have this x squared plus 4x plus 4. How do you color the region between these functions? So let's try. This is squared. And this one is Okay. How do I color the region in between? So I just put y is greater than or equal to y. Y is less than, it's greater than or equal to, it's less than or equal to what? It's less than, it must be less than this function. It must be less than g of x, but greater than, so as you can see, the inequality is satisfied, but it must be greater than this function. So it goes here, the intersection. No? So it colors the intersection. So it must be, okay. Okay. So this is how you color. And of course, you can also use a polygon. No? If for example, you use a linear function and your artwork is like composed of straight lines, you can use the polygon tool. Okay. And to close the polygon, you have to click on the first vertex that you clicked earlier. No. So for example, here E, you have to click E to close the polygon. And again, you can change, of course, the properties. Like, for example, you can change the color, no? And you can change, if you click on the settings here, you can also click, change the opacity of the polygon. And you can have other properties by clicking on the gear here. You can have more properties here, so you can just explore. Okay? Any questions so far? So that's for the math, no? You have to know the math to be able to create the artwork. We are talking about function art, so you have to use. First of all, the first requirement is, of course, you have to use functions in creating your artwork. So, any questions before we proceed? Okay, right. So, mukhang wala, no? Baka naman.
Maybe it's clear to them, sir.
Yeah. Hopefully.
Later, if they will be the one to use the GeoGebra, then all the questions will be.
Okay. So let's proceed. Let me look for the Apple logo. Okay. All right. So for the artwork, uh, depends on you. What kind of strategy you will use. Most students, they draw the artwork first, or actually many of them use drawing from the internet. No, of course not. Students are artistic. No, so what they do is they actually insert some picture, for example. So you can insert picture by clicking this tool here. It's called the slider tool, and you can use the image here. So if you click on the image, it will allow you to insert images from here, for example. Okay, so it will allow you to insert image from your computer. You know, and if you have the image, you actually have. Oh, what happened to the other point? You actually have the point. No, you have 2 points, and you can adjust. No, you can adjust the the size or the location of the. Give me a moment so I can show you. Let me take a screenshot of this first. Okay, so for example, I have another Let me open another window. So if I do this, I insert the image and I look at the images, no, from my, one moment, need to add it. I think this one, yeah. Okay, so I can actually adjust, no, using these points, no. So you can just adjust the location, and then if you want, you can just. I think you have to make this so you can see the if you, so you can see this the coordinate axis. You have to make this background. So settings, and then somewhere here, yeah. So in the basic, you can make it as a background image, so you can see the grid and the coordinate axis, and you can also change now the location and change the size. And if you again, if you want to remove the grid, no, you can adjust here. Or if you want to show only the, this is recorded, so you can look at this later. So if you want only to show the major grid, you can click on the chord on the graphics view and then go to settings. And then in the grid, you can show grid, but you can also choose major grid lines. So it doesn't have the smaller grid. Okay. So that's how you do it. Okay. So suppose you have positioned your artworks. This is the position that I want, for example. Okay, so let's summarize what we have learned earlier. So here, I want to trace this edge here. And for me, this looks like a quadratic function, and I can maybe cut from here. So what is the most basic quadratic function that we know? For the student, maybe he knows x squared, right? That is the most basic quadratic function. Now we learned what we have, we use what we have learned earlier. I want to move this by 2 units to the left. Now, what do I do? Do I add 2 from the, add 2 to the input, minus 2, add negative 2 to the input, add 2 to the output, or add negative 2 to the output? This is a horizontal shift, right? You can type your answer. We don't have time for you to is it the output? If I add negative 2 to the output, then meaning that's subtraction by 2. So it goes down, right? So another answer. Okay, so that's negative 2 to the input. Okay, so input means shifting left and right. So I can add negative 2 here. So add negative 2 means minus 2, right? Oh, it should be plus, right? Remember, it's counterintuitive for subtraction. For the input, it's counterintuitive. So it's the other way around. If you add 2, goes to the left. If you minus 2, goes to the right. Okay, so we have the correct vertex. Now, I want to shrink it a little bit vertically. So what do we multiply if we shrink vertically? Is it a number greater than 1, or is the number less than 1? I want to shrink vertically. Shrinking vertically meaning multiplying the output by a number between 0 and 1. So maybe I can guess a little bit, maybe 0.5. Let's see what happens. Okay, so almost, but I have a little bit of a protruding area here. So maybe I can reduce a little bit, maybe 4.4. It's too much. So maybe 0.45. Okay. So I think I'm okay. I think the graph is, I think the graph is okay for me. So if you magnify a little bit, you can see the vacant area here, but I think it doesn't matter because the artwork is not that large. So if you want, you can cheat a little bit by, oh, yeah. So changing the thickness. So I think this is perfect for me. Of course, if you have time, no, you can you can be as accurate as you want if you have time, no. Okay, now I want to change the domain because I want to cut the function from here and maybe up to here. This is -2, so a little bit to the right of -2. So this is between -4 and -5, but nearer to -5. So maybe I can put 4.8 maybe. So x is greater than or equal to -4.8. Okay. I can remove the label. So as you can see, GeoGebra automatically puts a label on the objects. And if I want to remove it, I just right click and then click on show label. Okay. It's a little bit protruding, so maybe I can do 4.7. By the way, if you click on the function, it becomes an if then statement. So this is a GeoGebra thing, so we can't really do anything about it. But be careful because here the domain is on the left side of the argument. No, so it changes when you click outside. So this is maybe 4.7, -4.7, and x must be less than or equal to somewhere here between -1 and -2, but nearer to -2, maybe 1.8. Oh, sorry, should be -1.8. Okay, I think that's maybe -1.7. So I think you get the idea. Of course, you have to approximate, no? But the difference here is that you know what you're doing, no? You know the mathematics. Because if you just approximate without knowing anything, without knowing about transformation, then I think it's very hard. That's why we had to learn the transformation earlier. Okay. Next, I want to uh, trace this edge here. So maybe it's the same as before. It's still quadratic function. Again, I can start from x squared just to show you. And then this time I want to move the graph by 2 units to the right. So what do we do with the equation? What should we do with x squared? You can type your answer. Okay, very good. Add -2 to input. Very good. So we have to add -2 to the input. So that's uh, and then squared, right? Okay. Again, I want to stretch. No, I want to shrink vertically. What do you think? So we have the experience already here. So I think it will be easier. Can we try 0.45 also? What do you think? Of course, I would assume that this is a bit, symmetric probably. It looks like symmetric. So maybe I can just put 0.45 also here as a student, no? For example, students will think like that, I think. And then I change this to 8 again, just like what I did earlier. To cover the vacant area here. And then I try to estimate again the domain. Try to change the domain from maybe negative, maybe it's the same, negative 1.7 here, maybe 1.7 here. Okay, let's try. So let's try this domain. So this time from 1.7 up to, can we try 4.7? Let's see. Okay, so it's not very symmetric because of this. Okay, so again, we remove the label. So we will subtract a little bit from 4.7, so maybe 4.6. Let's try 4.6. Maybe 4.5. It's still protruding. And a little bit short this time. I think you're getting the idea, no? Sometimes you really have to, so maybe 4.55. I think that's good enough. Maybe if you want to be more accurate, maybe 4.57, so almost perfect. Almost perfect. Okay. Next, I want to trace this, and I'm going to use another function. Well, of course, we can use again quadratic function that's um, opening downward, but I think this doesn't look like a quadratic because of the part here. This looks like a sine or a cosine function. Which do you think is more appropriate? What is the difference between a sine and a cosine function, by the way? So the sine function passes through 0, right? Passes through the origin. Let's try sine x. Okay. But I want something that is symmetric about the origin, and that is cosine x. So maybe I use cosine x, right? So I'll try h of x. Of course, you can shift, no? If you use sine x, then you can shift the function horizontally. Okay. And I want to reduce the height, no? This is, if you reduce the height, you are squishing vertically. So what should I do with the output? If I want to squish vertically, you multiply the output by a number between 0 and 1. So maybe let's try 0.5. Usually that's the starting point. Almost, but it doesn't fit here. It doesn't intersect the two points here, two endpoints. So maybe I shift it a little bit up. If you want to shift up, you add something to the output. So maybe plus 0.1, maybe. Okay. Now it's intersecting, but it's over the curve. No, so I want to reduce this also a little bit. Again, this is squishing vertically. So maybe I can reduce this to 0.4. Okay. Still higher, maybe 3. A little bit lower, so maybe 35. Okay. So it's very hard to be perfect. I think this is not a perfect curve, but let's try. Okay. Maybe it's good enough. So again, if you have time, of course, if you have time, you can make the curve as perfect as possible, but it doesn't have to be, because if I reduce the size of the artwork, you can see it doesn't make any difference. So if it's good enough for you, then you can just change it as you want. And then this time I change the domain from, what is the domain of the blue function, the cosine function? What should be the domain? You can type your answer. Okay. Let me see. From -2 to 2. Okay. Let's try. So from -2, from -2 to 2. Okay. No. What happened? Can you see the intersection? Can you see? Do you think it's better, or do you have a better number? What if I want to if I want the intersection or the junction points be exact, no? Exact means they have to intersect at the same point with F and G. What do you think should be my domain? Mhm. Of course, you can check the domains of the two, no? So this is from -1.7. So if I want this to be exact, this should be from -1.7 also. So they have to be in the same point, no? The intersection or the junction, we call it the junction point. Well, it's not technical, but I like to call it the junction point. And this time also, this is from here, you also have 1.7. So this must also be 1.7. So if you were to grade the student, now if I were to grade the work of the student, I would grade, okay, very good, 1.7. Medyo na-late lang siguro yung pag-type. I would grade the student, your teachers, right? So if I would grade between the one who used -2 and 2 and the one who used -1.7 and 1.7, maybe I would grade this one a little bit higher because of the mathematical reasoning behind it. So if they want to be more precise. No, if you are a math person, you have to be more precise, and that is very important also, right? So in some cases, you cannot use a function. For example, in this case, here, of course, you can use a function if you split the curve into two, for example. So from here to here, then from here to here. You can also do that, no? So splitting the arc, no, of a circle into two. But this time, We will not use a function. So you can use, you can learn other tools. But of course, in your artwork, we want you to use as many functions as you can, no? As much as possible. So you can use, in this case, you can use the circumcircular arc. What does it do? You can create an arc using 3 points. So for example, I have 3 points here. I can put the point somewhere in the arc. And then I can use this one. Circumcircular arc. Okay. And I can adjust now. Of course, you can draw directly. You can just draw the arc using any points, and then you can adjust later. You can adjust the 3 points now. Okay. What does this mean? This is another mathematics that you can learn. No? So given any 3 points, actually you can create a circle. Given any three non-collinear points, so if I have three non-collinear points, I can always create a circle using these three. See, I can always have a circle even if I drag them anywhere, as long as they are not on the same line, they are not collinear. This is a good thing to prove, no? How do you know that it's always a circle? Something for you to think about. It's outside the seminar, but that's something to think about. So again, if you have your artwork, you have to hide the unnecessary objects. No, you want your artwork to be aesthetically pleasing. Therefore, we don't want other objects that are not needed. So you can hide. You can hide, but the hidden objects are just here. So you can reveal them. You can show them whenever you want. No, it's just here in the algebra view. Okay. Okay, I want this to be 8. I think you get the idea. Okay, here I can also use we don't have time, no, so I will just use the circumcircular arc, maybe here, and also here. But for these two, actually you can use, I think you can use exponential function here. Okay, you can use e to the x and then translate it up. So I don't, you know the shape of e to the x, right? Okay, and then maybe translate it up. Where is it? Plus 8 maybe. And then, you can make the translation, so on. You can translate it to the right, maybe -2. Okay, something like that, and then up again, and then you can make that transformation. No? But we don't have the time to do that. It's for you to explore. And again, we want you to use as many functions as you can, because the other tools, they are not really challenging. They are just drawing. They are not really mathematics. No. So if you use the line segment, for example, this is just drawing. So this is not mathematics really. It has some mathematics, but it's not really challenging. It's like using a pen to draw. So it doesn't make sense to use it. Of course, you can use it in other. There are cases that you have to use. For example, the vertical line. Of course, there's no vertical line. That's a function, so you have to use the line segment tool. So if you want to construct a vertical line segment. Okay. And then maybe I can also use here. We are just saving time, no? Because we don't have a lot of time. I want to use sine function here in this part. So let's use sine x this time because we already used cosine x. So let's try j of x equals sine x. Okay. So this time I want to shift this up, but before that, let's clean. Maybe let's clean the other points first here. Okay, I want this to be 8 to be uniformed with the other. This one, I'm not going to move this, so I'm going to fix it. Just finalize and just remove the unnecessary objects. And also the labels, again, you have to remove the labels. Okay. We should be done by 10:30. I think we are a bit early, but you are college students anyway, so I think it's okay. Right, so I want to shift this up. Shifting up means adding to the output. So this is 10, so maybe this is 8. So I shift up. I want this to go here. So this is shifting to the right, meaning this is almost 1.7, right? This is -2, so maybe this the bottom part here, or the minimum is probably negative at x equal -1.8. So I have to move to the right by 1.8 units. So I have to use the input. Move to the right means minus, right? Minus maybe 1.8. Oh, it's too much. So maybe 1.6. And then I want to move up a little bit. So maybe 9. Okay. It's not really exact. So I have to move to the left for a little bit. So I have to add maybe 1.7 or 1.9. No. 1.4. One moment. Wait. So I think you get the idea. Okay. And then I want to squish it vertically. So I have to multiply the entire function by entire output by maybe, it's not just 0.5, it's probably smaller, maybe 0.3. So as you can see, you make several adjustments because before you can really make a perfect, or at least not perfect, but close to the actual curve, no, in some cases. So I'll subtract something from here, maybe 8.7. Okay, and then shift. And this is a vertical stretching a little bit, but I think you get the idea. No, we don't have to really make it perfect, but 0.6 maybe. And then again, I have to move this up a little bit. Okay, so I think that's close enough, but I think you get the idea. Any questions? So you have to move this here and here also, and make my domain. What is the coordinate of this point? -1.49. So maybe 1.5 is okay. X is -1.5. And maybe, what is the coordinate of n? Coordinate of n is 1.09. So 1.1 is okay. What happened? Should be negative. Okay, so I think we got it. Of course, you have to clean your artwork and you are done. All right. So how do you save your artwork? Well, you can, of course, save offline. Nandyan pa ba kayo? Are you still there?
Yes, sir.
Okay, good, good. Right. So you finished
They're
your artwork?
amazed, sir.
Oh, thank you. I'm glad that you like it, no? So we are done with the artwork. How do we save it? So again, we can go here. We can save it online, no? If you are logged in, you can go to geogebra.org, by the way. You can create an account. GeoGebra. Okay, so you can create an account here if you are logged in. I'm logged in, so you can see my picture. So if you are logged in, you can see all your resources here, no? Um, if you are logged in, you can see your name here. If you're logged in, you can directly save your file. So if you save this online, I am logged in, then I can just save it. Bukso ang ano niyo, sir, no? Tama ba? Is this the
Yes, po,
acronym?
bukso.
Okay.
Yeah, that's correct.
And then when I go to my profile, if I refresh my profile, mapupunta na siya doon sa profile ko. Okay? But if not, you have to save it. You have to download it or save it offline, and then you can upload it later. So if you're on your profile, for example, you are not connected to the internet, you have to create, if you're logged in, and then an activity, and then you can, no, no, no. You can upload, sorry. We will have resources for this, so don't worry. You can create and then upload, and then look for the file that you created. Just a reminder, you have to resize the window that you want to, you have to resize the window appropriately. Huwag kayong malit yung artwork nyo and then your window is too big. No? So we don't want to do that. Okay? So I'm going to show you some sample outputs from the students, from high school students that, so these are some of the outputs. So for example, this one used 75 functions, 45 functions, this one 139 functions. Some of them use a little bit, small number of functions. Okay, this one used 114 functions. In some cases, they use all the curves are functions. No, some students do that. No, they are very enthusiastic about it, and I think your theme will be culture. No, from Bukidnon State, from Bukidnon. No, and these are some of the students. We also have history and culture in some of the schools, and as you can see here, 210 functions. So that's a lot. This one is 192 functions. So I think the most number of functions that students used was 400 plus, I think. So, okay. So later on, we're going to give you some resources. We're going to give you the PowerPoint. And we also have what we call the GeoGebra guidebook. I'm going to give you the link later. So all the things that we have discussed, so these are the transformations. We didn't discuss reflection, but you will see it here. You can study it. We have coloring regions, so you can actually interactively type here, for example. Oh, I don't know what happened, but there's no supposed to have an input bar here. I will check later. And you have also the video. So the video on creating the Apple logo, it's here. You can watch it, rewatch it if you want. And there is also a function art webinar, the actual webinar that happened. So per transformation, if you want, you can have that. And here you can managing your files, creating a GeoGebra account, but I don't think you need it. This is for high school students, so You can just create your GeoGebra account. You can save your file on your computer and so on. But you can look at them now as your um, reference. No, we will also give you the PowerPoint handout. Okay, I'll just update the links and we'll give to Sir Darren later, and Sir Darren can give it to you. And just to motivate you a little bit, if you are not motivated enough, what I showed you is actually just the tip of the iceberg. You can do a lot with the GeoGebra. If you look at my profile, I actually have, I don't know, hundreds of artworks of a 3D that I've created. So it's not just 2D. So for example, this one I created several, actually many 3D artworks. For example, this one is an umbrella modeled using GeoGebra. So this is in 3D. So you can do a lot, no? This is a bridge. I saw this on YouTube, and modeled it. And of course, there are a lot. Mathematics, for example, there are mathematics. Not just, so for example, you're teaching domain and range. So this is the concept of the domain if you're teaching in high school. And a lot, you can do a lot. This is limits. What did I do here? So if you want to teach limits, and of course we have art, no? So I have created some art also. That's one that's the stuff that I created. You can also, for example, you can, proof in GeoGebra, for example, you can also do that. Like for example, the proof that the volume of a cube can be broken down into pyramids, like so. Why is the volume of a pyramid divided by 3, right? The volume of a cube divided by 3. So stuff like that. And of course, you have, of course, concepts in 2D, like for example, derivative, for example. What does derivative really mean? Let me search. What does derivative really mean? Huh? When you study derivative, it's the slope of the function at a particular point. No? And if you trace the slope, for example, this is the cubic function. If you get the derivative, it becomes a quadratic function. Diba? So what's really happening? No? So if you're teaching high school, if you're teaching university, you can use these applets. So you can look at my profile. Of course, there are a lot. Aside from me, of course, there are thousands of GeoGebra creators. No, so I can give you my profile. You can use later if you want to explore something, or when you teach. No, right. And not only that, no, GeoGebra can also be used for AR, for augmented reality. Let me show you something. Just give me a few. I think I uploaded somewhere on YouTube. Um, One moment. Oh, this one. So this is one of. So you can use augmented reality in GeoGebra. So I created this Taj Mahal model, and you can actually use it uh, augmented reality. So this is our office here at JKU in Austria. So you can just move around your phone or your tablet, and then it took a while now. It has to detect a flat surface. Sometimes it's taking a while because of the rough surface here, because they're using carpet. And then there you are. So you can put your model in augmented reality. And you can move around and explore it. No. So that's the things that you can do with GeoGebra. So you can do a lot. No? It's very, very powerful software. I know a lot of students also know Desmos, no, but Desmos is also a good software, but it doesn't have this feature. Okay, so that's one. And of course, you can also do 3D printing. Let me show you some 3D printing that I did. I don't know if you can see it. So this is maybe I should remove my background. Let me remove my background so you can see it. Uh-huh. One moment. One moment. I think we are a bit early. I was expecting to finish like 10:30. I think we can finish at 10. Let me
After
remove
all
my
those trainings, sir, you are good now in time management.
yeah. Yeah, I have implemented it probably more than
Mm,
20 times already. So
yeah.
I've worked with a lot of schools and several and many, many times. No, from one school we implemented like 3 times, 4 times already. So this is my apartment, my dorm here. You can see the background, I think. And you can see here, this is a 3D printed output of the Taj Mahal that you saw earlier. So there is no
Mm.
intervention here. Directly from GeoGebra, you download as STL. It's the STL file, and then you put the file in the 3D printer, and this one prints. I think the printer here can print this for maybe 3 hours. So it's a bit intricate. So maybe 3 hours. It's a good printer. You're using Prusa here. But I think maybe there are printers now which can print this a little faster, maybe 2 hours. So you can use 3D print with the GeoGebra. Okay, so I don't know if we're going to Sir Darren is going to give you more
I'll be
uh,
the one to give the details, sir,
yeah,
on
the
the
details, yeah, of
assignment.
the requirements. And I think I don't know, no, Sir Darren, if you maybe want to give them the minimum number of functions that they can use. No,
Okay.
you can just draw. No, if you draw, it doesn't make sense to use line segments.
Mm.
Otherwise, you just draw using your pencil. So maybe you can use functions, and maybe you can just maybe you can later we can talk about it.
Um, yeah, we will have the details, sir. Like,
Okay, so that's basically it. I don't know if I have something else. Let me check. Let me check my slide. No, if I have forgotten something. Yeah, I think that's it.
mm,
I showed you some examples of the students' artwork, and I think that's it.
can we ask some students, sir, to share what they learned and insights about this training? Maybe we could hear some from them. Is Roan around? Hello, Roan. Because I can see
Good
that Roan
afternoon,
really is
sir.
very participative. Hello. Maybe you could share your insights or what did you learn and the things that you would like to share for the group about this training.
So about this training, I'm always using my TikTok account, and in my For You page is always yeah, there is GeoGebra. We have how do you know logo designers make designs, and yeah, they do functions as well. Also, uh I'm also fond of that one researcher in, I think that was Harvard or ano, British University, that makes artworks using functions also. And I didn't believe, or I didn't think that one day I will be making one of my own too. So it's kind of um fluttery, and I'm excited.
Great.
Thank you for that, Roan. Maybe you could also ask, where is Gabriel? Hello, Gabriel. Are you around?
And maybe if they
Hello,
have
Gab.
some questions also, sir, maybe later.
Yeah, okay.
Gabriela. Reaction or question, maybe. I don't know.
Who would like to share insights also, aside from Roan? Anyone? How about Gabriel? Hello, Gab.
Hello, sir. Good afternoon.
Hello.
First of all, just allow me to take this moment to say thank you to Sir Guillermo for
Mhm.
for sharing your expertise to us, sir. And siguro insights for this webinar is I'm really thrilled about the things we've learned today because as a mathematics major, we've done a lot of graphing using Desmos, but I haven't imagined that we could use graphing software to draw something. So this is something new for me. So I'm really grateful for this opportunity to learn something new that we can use in our major, especially in the future if we will be given a chance to teach in high school or maybe in college in the future. Thank you so much, sir, once again. Uh, from the bottom of our heart, uh, in behalf of everyone, we're very grateful for the expertise you've shared upon us. Thank you so much.
You're welcome. And the others also, you can talk in Tagalog if you want it. It's Tagalog is good also. We're not very particular of the language. I'm not very particular.
Thank you, Gab. Some more? If not, if you have questions, you could also ask. Aside from your reactions, you could also ask questions. Would you like? Or what are the things that you have in mind already now, ways forward? But I'll be giving you the details about the ones that you'll be doing after this, because we'll be giving you 1 month to make the artworks that you will be doing. But it will be I'll be giving details to it, especially the context that we will go with the culture part of it, like Bukidnon culture, if possible, and maybe also on the number of functions that will be placed on the different artworks that you will be using. So we'll have more on that. Okay, yes, yes. Don't be shy if you have some questions. Anyone? Hello? Or if yeah, because I think one of the things that you learn now is using the cell phone for the GeoGebra is it will be difficult, right? Because they
Yeah,
tried, sir.
quite
Yeah, they
difficult,
tried.
but yeah,
Yeah.
it's quite difficult, but students did it. So
Oh
if
yeah,
there's really
there
no
was
choice, no, maybe I can show them some
sige, samples
artwork
are
from
on
the
the
students. Actually, this one,
that it's
actually this one was created using, I think this one, and
cell
also
phone.
yeah, and also this one. This is created using cell phone.
Mm.
So pag wala talagang choice, no, for example, you don't have any computer at home. Students in high school have did it. So if you really want
Mm.
it, you can. I think you can do it.
Maybe they could
A lot of
try, sir, now
a
to
lot of
start.
students also. I think somewhere here, this batch has a lot of cell phone. I think so. This lion is created using
Mm.
functions. So as you can see here, you can see this vertical format. These are created using cell phones. Makikita nyo kasi vertical siya, di ba? So this one, most of these students, they use cell phones in creating their artwork. See? So this is vertical. These were created using cell phone because they save from their cell phone. So
Mm.
automatically it's
It's using the cell
becomes
phone.
vertical. The format is vertical because of the shape of the cell phone. So a lot of students
Mm.
actually use because they didn't have computers also at home. So this
So
is
it's good, sir, that they
mhm.
could also explore that
Yeah,
because I think
this is also good,
most
sir,
of them.
because you can talk about yung equity because
Mm,
in many of the activities in high school, you cannot do it because computers don't have
mm,
students don't have computers. But for this activity, even for students with only mobile phones, they can do it. So
mm.
this is one like facet of
Yeah,
the project that's advantageous for.
yeah, it's advantageous for the students.
Mhm.
Okay. Thank you for that, sir. Any more questions if you have? Hello? Yes, Miss Singaya. I'd like to say thank you. Okay. They realized that functions can be used, sir, not only abstract in nature, but also
Yeah,
existing in real life.
yeah. Actually, everything
Yeah.
can be modeled by math. Almost everything, I think. Mhm.
I think they're appreciating it, sir, because they're usually solving functions in the classroom and illustrating functions, but there's no actual application of it. But now they could have actual application of it. So I think they're excited on the artworks that they will be doing and what functions can they use and explore more. Because I think they are doing sine functions and cosine functions, but they cannot really see to it in the real sense in its use. So now I think they can make use of it in doing something like artworks.
Yeah. So we have a lot. We have papers. I have papers on under review, no? So we can give it to them once it's published.
Mm.
Even though you're doing art, but you're actually doing a lot of mathematics, and that's what's good about
Mathematics.
this, no? There's a lot of mathematics going on in the background if you do your artwork. Like you learn about domain because I know, for example, defining the domain on a particular interval. They don't usually teach that in high school. They just say, "Oh, what is the domain of, for example, exponential function? What's the domain of this function?" But they don't actually do that. They don't do the activity where they are the ones defining the domain. So in this artwork, they are the ones defining the domain. So
Mhm.
and they also don't, in high school, they don't also do the transformation. They just say, oh, y equals mx plus b, and m is the slope and b is the intercept. But they don't usually adjust m and b to really create a particular graph. So this is something that relates the algebra and the geometry, and the students are doing it on their own. So this is actually a good area of study,
Mhm.
especially for the new teachers also. They are going to
Yeah.
be teachers soon. So yeah.
Because I think not much studies on the pre-service teachers, or
Yeah.
especially on the GeoGebra and their actual outputs. Maybe
Mhm.
that's one of the research space that you could also explore.
And I think they are very lucky because they are the first
Mm.
pre-service teachers that I gave this webinar.
Yeah, you have trained.
Yeah, yeah. So just when you teach, just send me a
Um,
message. We can
yeah, they could
collaborate.
also have this on their internship. They could make use of GeoGebra in teaching the different concepts if they could.
Mhm.
And also in their mathematics research, they could also make use of this in their mathematics research, as
Yes.
well in their I think CBAR
Mhm.
classroom-based action research.
Yeah, we can do
So,
that.
sir, can we have a picture taking first before we
Yes. Yeah.
end the session? Everyone, can you open your camera so that we could see you in that picture taking? Hello? Okay, thank you very much. They're at home, sir,
Mhm.
because our Wednesdays are more on student activities, and I think not all Wednesdays have activities, and I think that's why we chose this Wednesday because this is the Wednesday that they are not in
Mhm.
school to have some activities.
Mhm. Would
So
be good to collaborate with them. You know, these are younger teachers, younger blood, and
yeah.
they have all the drive, you know. I think I like them if they have be more active no in research and in teaching no. Sa
Yeah.
ibang bansa hindi lang sila nagtuturo yung mga students, they also do research. In Indonesia there are a lot of teachers who publish. So if you look at the internet, if you do some research, maraming from Indonesia. And I think we have to also do that in the Philippines because we are really lagging behind. So
Mm.
hopefully in the near future I can work with you. You are the first batch of
Yeah.
teachers that I first batch of pre-teachers, at least in the recent, because I've been training teachers for 20 years now.
Yeah.
In the recent, you are the first batch of teachers that I trained in function art.
Mm.
So hopefully I will hear from you when you teach and do
I
we
think
can
when you will be back from in the Philippines, sir, especially when you are with NESMED already, I think you'll have more like this
I'll have
for
more.
the
Yeah.
in-service and the pre-service
Yes,
for
yes.
this.
I'll be back maybe next year, sometime in maybe from February to June. So I don't know yet, but maybe the latest would be June next year.
Okay. Okay, I'm taking a picture. Anyone? Okay. So this is the first frame. Okay, second frame. Thank you everyone for attending. I noted the attendance, don't worry. I really check one by one who really are into the Zoom and who participated. So don't worry, I really check the attendance. That's why I really here. And then I'm looking forward of the outputs that you'll be doing. But I'll be the one to give you the instructions and the details. And
Mhm.
also um I think we'll be giving you a month to do it, and then I'll be connecting again to Sir JR for the outputs that you have
Mhm. And we will also give
and
you the resources that we did in the
resources.
book
Okay.
earlier, so they can look at it also. And if they want the whole video of the
Mm,
this video, if they want, they can. We will upload this on YouTube and give you a private link.
mm.
So
Sir JR, thank you very much for
welcome.
this because this is really an opportune time for us to learn more on this because I think GeoGebra is not really much utilized really in especially in the university right now.
Mhm.
I think they were exposed to Desmos
Yeah, yeah.
much.
This is also
Uh,
good.
yeah, me personally, not much on that side. So we really like to have more on this, especially on the technology side
Yeah.
because right now we can actualize mathematics using technology.
Mhm.
The abstractness of mathematics can be with technology, and I think the students I have with mathematics in the modern world, they can really see now the different
Mhm.
concepts that they have, especially on that. And I think the number theory class also that I have because it's two class. One is number theory, the other one is
Mhm.
because they could have. I think mathematical investigations, and they can make use of the GeoGebra
Okay.
to actualize it especially in its abstract nature. So
Mhm.
thank you so much, Sir JR, and we're looking forward for the output of this students that we have here, and I'll connect it to you later
Okay.
soon.
Okay, sir. Do you have 5 minutes, sir? After this?
Yes,
Okay,
yes,
so
sir.
maybe
We
the
can
students can leave and then we can
okay
for maybe 5 minutes.
for the details.
Uh,
Okay, thank you everyone for listening and coming. You can leave already, and I'll talk to you on our class on Friday about this. See you. Bye bye.
bye.
Bye bye. Thank you, sir.
Bye bye, everyone.
Thank you, sir.
You're welcome.